Today we're solving polynomial expressions in factored form. A polynomial is in factored form when it is written as a product of factors. You can see the difference here. In standard form, we have the two monomials that make up the binomial. This would be the same thing here, but in factored form. Here we have a trinomial, and this would be the factored form of it. So we'll be talking about that, but these are the difference of factored versus standard. The standard form that goes to that factored form, and that standard form turns into that factored form. When one side of an equation is a polynomial in factored form and the other side is 0, we use the 0 product property to solve the polynomial equation. The solutions of a polynomial equation are also called the roots. We'll hear other words that we use for these same roots in a future lesson. The zero product property tells us if I have the product of two numbers that is 0, then at least one of those numbers has to be 0. So we know that from just knowing our numbers and our multiplications. For example, 5 times 0 equals 0. Well, the 5 or the 0 has to be a 0 to make my answer a 0. Negative 2 times 0 is 0. One of those numbers has to be a 0. And we're going to use this property as we're solving these polynomial expressions. So let's look at a few examples. So in this first one, we're solving the equation. So the zero product property says that one of these numbers, or in this case expressions, has to be 0. 2x times 4x minus 4 equals 0. So the way we do this is we take each expression and we make it equal to 0. So the zero product property says that either 2x has to equal 0 or x minus 4 has to equal 0. So basically what we do is we make each of those expressions equal to 0 and then solve them separately. So obviously for the first one, 2x, we divide by 2. If x was 0 and I plugged it in for 2x, that would become a 0. And then no matter what the x minus 4 becomes, it would make the equation true. Or if I plug in x equals 4, then the second expression would now be works to 0. And then no matter what the 2x was, the number times 0 would still be 0. So when you want the solution, the x's could be 0 or 4. For the next one, we would take these two expressions and set them to 0 and then solve. So if x was 3 or x was 9, there would be my answer. Both answers would work. If I plug in a 3, it would work. If I plugged in a 9, it would work. So both answers would be acceptable. When two or more roots of an equation are the same number, we call those repeated roots, which kind of makes some sense. You're repeating the same number. And here's a couple of examples that you would see maybe that happening. So for the first one, if I said 2x plus 7 and 2x minus 7, if I make those both worth 0 and solve, Notice we're not going to get the same answer, and it's important that you notice that there are two answers here. So we get negative 7/2 for one, and then the second one is positive 7/2. So don't just think that there's the one answer there. Now the next one's interesting because when you see this, x minus 1 squared equals 0. Well, if you think about it, that's really x minus 1 times x minus 1 equals 0. Well, I don't really need to do both of those to the 0 property because really they're the same expression. So here's a case where only one answer is going to come out. I won't be getting two answers for that one because there's only one type of expression, x minus 1. And then on the last one, we would then subtract 1. To get our answers of negative 1, 2, or 3. All three of those answers would work into that equation because using one of those three numbers would make one of those expressions 0, and then when I multiply it by any other numbers, I would still get 0. So it's a really important property to make sure we understand. You've already used it in your life with just numbers, but now you'll be using it with variables and numbers in some factoring of polynomials. So now we want to solve a polynomial expression with a zero product property. Sometimes what we need to do is factor. Or write it as the product of two polynomials. What we want to always do first, we want to look for the greatest common factor, or the GCF of the terms. This is, as you know from other GCF work, a factor that divides evenly into each term. So GCFs are very similar to when you've done them in the past, when you would have two numbers like, for example, 2 and 6. There's a greatest common factor between those two things of a 2. Then you look at numbers like 6 and 12. Well, there is a common factor of 2's, there is a common factor of 3's, but the greatest common factor would be 6. It's the same idea in our polynomials, but now we're looking for the greatest factor that's a term. Could be number and variable combination, could be variable with variable combination, the greatest common thing that we can pull out of all of our terms. So here, let's look at this first example. Factor out the greatest common monomial factor from 4x to the fourth plus 24x to the third. So first, just think about our numbers. What is the greatest common factor of 4 and 24? Well, the greatest common factor would be 4. It's in both. So I'm going to kind of pull that out. I need it to stay a 4 and a 24, however. So I can't just take out the 4 and then let everything else fall away. So think about, on the inside, that would leave me with a 1 and a 6 if I was to kind of go backwards and kind of pull out the 4. Now looking at my x terms, I have 4 of them there. And I have 3 of them there. So what's the greatest common factor? Well, x cubed is the greatest common factor. Now, if I divide the x cubes out of 4x to the 4th, I would have 1x left over. And if I divided 24x cubed by 4x cubed, I would have 6 left over. So that would now be, in more simplified form, the greatest common factor pulled out of 4x to the 4th plus 24x to the 3rd. Now remember, I can always check this if I did my distributive property. If I did 4x to the 3rd times x, yes, I do get 4x to the 4th. 4x to the 3rd times 6, yes, I get 24x to the 3rd. And it's important that you can do that. When we do our factoring, we want to still have the same answer as we started, but it's just pulled differently. In this case, just the greatest common factor is coming out. So the next one we want to take out and solve by factoring. So here we're solving an equation. So what I'm going to first do is I take out and see, is there a greatest common factor? Well, looking at 2x squared and 8x, I can see 2x as a common factor. If I was to remove 2x, I would have x plus 4 on the inside. And again, if you do your check, 2x times x is 2x squared. 2x times 4 is your 8x. Well, now with the zero product property, I would say 2x equals 0 would work. X plus 4 equals 0 would work. And then when I divide by 2, x equals 0. So my answers would be 0 and -4. Now in the next one, you got to be careful. We don't have our equation set to 0 yet. So the very first thing I have to do here before I start thinking of greatest common factors is to turn my equation into an equation with the 0 on one side. So notice the way I did that was I just subtracted 15n from both sides. Once I have the 0 on one side, then I can use my greatest common factor. So what is the greatest common factor of those two terms? Well, I can see 3n as the greatest common factor, leaving me with 2n minus 5. So then, with the zero product property, I make those two expressions equal to 0, and then I solve. So my answers are 0 and 5 halves. All right, lastly, here's we're going to do a word problem to see how this works. We're looking at the arch of the fireplace. So we have an arch. It's kind of set up around an x and y axes at this point. They're giving us the equation y equals -1/9 x plus 18 times x minus 19, where x and y's are measured in inches. The x-axis represents the floor height. So think about that. This is the height at floor level. The width of the arches is also here at the floor level right there. So we want to look at what are the the width here at the largest part. We're looking for the width at the floor level. So the hint here is at the floor level, if you think about it, we're at the y equals 0. So with that in mind, I can take the y out of my equation, and I'm going to get my equation, instead of being y, it is now 0. I could also find the height at, the width at different areas if I said I want to know it at 10 feet, and I want to know it 20 feet, and then I would plug the y in, and I can find that width. But at floor level, it says 0. So because of that, the zero product property is now perfect to use here. Makes this one actually super easy. You don't even need to think about a calculator. Okay? So if you think about it, the very first thing I'm going to do before I look at my zero product property is to divide both sides by this negative 1/9. If I divided both sides by that, 0 divided by negative 1/9 disappears, and the negative 1/9 disappears on the right. So then, using my zero product property, I would have those two expressions set equal to 0. I would subtract 18, and I would add 18 to this one. So once I've done this, I now know that this x value is 18. This x value is negative 18. So with that in mind, I know that we have a width of 36 inches at the floor level. And that's where we're going to be seeing harder equations coming up that we need to be able to factor, use our zero product property to help find solutions. And notice that there have been 2 solutions for most of these. So this is the beginning of our factoring lessons, a very, very critical piece of our algebra this year. And please feel free to ask any questions. It's important that we understand these as we go forward. And I will look forward to seeing you in class.